When we're thinking about the columnar stores, such as the ORC file format, there are additional things we can do. We've talked about how partitioning gets us very far from eliminating folders full of files. But if we know a little bit more about the predicate, maybe in this case we have a table that we're going to call orders, and we're just trying to, for a moment, just assume maybe it's partitioned at a day level, so we have a day's worth of orders, just that one folder. And then just to keep it simple, our schema is simply order ID, an amount, and maybe a sales rep. And if we know we're going to query on the sales rep, especially one or a few sales reps, even better if they're kind of in a band, 101 through 107 or something like that. But let's just take an example of just doing a situation where we're looking for certain sales reps. So what do we show here is we could use a concept, a simple concept just called sorting, or maybe total order sorting for this whole partition or even this whole table if there's no partitions. So what I'm trying to show you at the bottom again is just that maybe we built out this situation where we only have about enough data for about 5 files, but if we sorted it when we built this this table or this partition, and if we ordered it, as you kind of see here, by their sales rep ID, what we might get is things like you see here, 101, and maybe through the 103, the next one picks up on 104 and works its way to about 123, and so on. You can kind of see a pattern: 123, 301, 303, 507, and there are going to be scenarios where that number, fits in one side and also in the next. It's not the end of the world. Now, if we did all that, as opposed to what you kind of see at the bottom here, if we didn't sort it, then every file would likely have, sales reps 101 through 999 using these simple examples over here. So that's what these 5 files might have in them. So when would it matter? It would matter when someone read a select on this table and they added a good old where clause where the sales rep, and let's just say equals, I'm just picking one off of looking down below, maybe 111. When we do something like that, what we have the opportunity to notice is when we do mins and maxes, we'll query this guy and he says, 101 to 103. Nope. He'll query this guy. And when I say query, he'll read the header information. Who? The SQL engine, Trino, in this case, Hive, or anything else, to be honest. And he'll see that and he'll say, great, I found this file has the opportunity to have 111 in it because it spans 104, maybe down to 123. He'll also be looking at the other blocks here, the other splits here, the other files here, and we'll notice that none of them could potentially have our sales rep of 111. So what this lets us do is quickly abandon, in this case, 4/5 of the data set. So we don't have to look any further. If we did the bottom, like I said before, we actually would have read all of those, and since they're not necessarily sorted anyway, that time will be consuming based. So maybe let's just have a little bit of fun with it. We'll just change one of the things. Maybe instead of a sales rep equals, we'll just do an in, and then maybe here we'll do the same thing. We'll do 101. Maybe I want to do 200, and also 507. Now this one's a little tougher because we're actually going to hit quite a few of these. So we're going to quickly ask file 1. All this happens in parallel. Hey, what's your min and your max? My min and max again are 101 to 103. So we know, hey, we're gonna find this guy in there. If he's around, we're gonna find him in there. We're gonna look at the next one. It has a min and max of 104, 123, and we say walk away. There's nothing else to do. So we are gonna read this one. We're gonna walk away from the next one. Then we see 123, 301. And this is our opportunity maybe for 200. So we definitely need to kind of look at this one. And then lastly, or not lastly, we'll look at the next one, 4. And we'll see 303, 507. Nope. Oh, wait a minute. It is in here. So we'll actually take a look at that. And since the next one is 507. So I gave you kind of a worst case we actually have to read all of these different partitions, all these different files that were total order sorted across there. But we also have a little bit more benefit by the fact that since we put them in order and there's other things going on inside that ORC file, we actually kind of get the benefit. It's not implemented as a classical B tree, but there's that concept of, cut this thing in half and say, hey, I'm looking for 507, what's here? Okay, it's on this side, so cut this in half. We looked at this first, and then we said, okay, how about the next line? Is it above or below? It's below, we cut it in half. So we can quickly, based on those indexes at the file, and at the stripe and so on and so forth, help us quickly find that information. All right, hopefully that concept helps a little bit. And as I said, really the best examples are when we have a bunch of files, and I was keeping it kind of simple here and not putting tons and tons of things, but imagine there were 50 of these, 100 of these, and even in a scenario like we just showed there, or even a range or something greater than, less than something on that sales rep predicate, we can go a little bit further. So we don't necessarily need to do this unless we have this need where we see this predicate occurring often, but it actually can give us yet another way and another way to do less work, and we can think of this as implementing some kind of maybe an additional index on this table. All right, I hope that helped a little bit. Thanks.